Every year, millions of tons of agricultural residues are generated around the world. These materials are often burned, discarded, or left to decompose without purpose. At the same time, soils lose nutrients, biodiversity declines, and architecture continues to consume resources rather than regenerate them. As ecological systems become increasingly fragile, new relationships between design and nature must be imagined. In San Cristobal Tepeteopan, Tehuacán, a community deeply connected to corn agriculture, large quantities of agricultural residues are generated each harvest season, revealing both an environmental challenge and an opportunity to rethink waste as a resource for regeneration. What if waste could become a structure? What if architecture could grow relationships between humans, materials, and ecosystems? These questions led to the development of INTERSER. What is mycelium? Mycelium is the vegetative network of fungi. It is composed of microscopic filaments called hyphae that spread through organic matter. As it grows, mycelium decomposes material, redistributes nutrients, stores carbon, and creates connections between living organisms. Often referred to as nature's underground network, mycelium plays a fundamental role in soil regeneration and ecosystem resilience. In INTERSER, mycelium becomes both a biological material and an ecological agent. What is bacterial cellulose? Bacterial cellulose is a natural biomaterial produced through microbial fermentation. Unlike plant cellulose, it forms highly hydrated membranes with exceptional water retention capacity. These properties create favorable conditions for biological growth and nutrition exchange. Within INTERSER, bacterial cellulose acts as a moisture-retaining medium that supports and accelerates mycelial colonization. Together, both organisms form a collaborative living system. The development of INTERSER emerged through a process of experimentation and material research. Multiple substrate compositions were tested using agricultural residues from corn production. Different containment systems, moisture levels, fabrication methods, and growth conditions were explored. Several strategies were evaluated to determine how a living material could remain flexible, scalable, and capable of supporting future ecological interactions. Through this iterative process, a system based on mycelium, bacterial cellulose, corn waste, and textile growth channels began to emerge. How the tubes are made. The process begins with collecting and preparing corn agricultural residues. The material is cut, measured, blended with water, filtered, and thermally treated to reduce contamination. Once prepared, the substrate is inoculated with mycelium spawn and bacterial cellulose. Instead of rigid molds, the mixture is introduced into cotton fabric sleeves. These textile tubes create a breathable environment that allows biological growth while maintaining flexibility. The tubes are then sealed and incubated as the mycelium gradually colonizes the organic material. Over time, the resulting elements become living conduits capable of distributing moisture, nutrients, and biological activity throughout the system. The pavilion. INTERSER functions as a public pavilion and ecological infrastructure. Its lightweight wooden frame acts as an initial scaffold for biological growth. The network of mycelium-filled tubes connects the structure, creating pathways for future ecological interactions. Rather than resisting nature, the pavilion is designed to collaborate with it. It provides gathering space, environmental education, and opportunities for collective engagement. Architecture becomes a host for living systems. INTERSER is not conceived as a static object. It is designed as the beginning of a long-term ecological process. As time passes, the biological network continues to expand behind the architectural frame. Mycelium gradually reaches the surrounding soil. Organic matter accumulates. Nutrients become available. Soil structure improves. Moisture retention increases. Plant communities begin to emerge. Insects arrive. Birds establish new habitats. New ecological relationships form. What began as agricultural waste evolves into a regenerative landscape. The pavilion slowly transitions from architecture into ecosystem.